Back in 2022, one of my very first few projects on the microbit was the music player, by which utilizes the Grove speaker that comes with the kit. And from the following speaker, I actually learned of the function beep that allows the speaker to beep at a certain frequency. Fast forward to a few years, leading up to today, I would like to present to you all the BeePy Sound Module. Let us now begin. Here are all of my pertinent information. Feel free to pause the video now in order to verify them. So let us now begin with our introduction. Take the smoke detectors, thermometers, and heart rate monitors. What do they all have in common? Firstly, they output information as sound, and these sounds comprise of beeps that can be played at a certain frequency. And lastly, these beeps play with varying duration of time, or in my words, beep time, and have intervals or delay in between. And from the following, I have formulated two possible functions that allow me to apply beeps into everyday life. First and foremost, the Pytronome and the MorsePy. But first and foremost, I would actually like to introduce to you all the beeper class that I have made for this program. Within it, we have the following variables: delay seconds, frequency, and beep milliseconds. These can be used in order to instantiate into the beep instance method that allows for custom beep setup. And lastly, we have the class methods dot and dash that allows the user to use and create dots and dash like in Morse code. Moving on, we also have Pytronome, by which utilizes the functions Pytronome setup that calculates delay time using BPM and returns a beeper object with the custom setup. We also have Pytronome that initiates the setup and loops the object using the beeper.beep. And from the following, we also have the following user interface via these options: reset, menu, and leave, by which are prompted using the keyboard hit and get character function of the library MSVCRT. Moving on, we also have MorsePy, by which uses the following functions to Morse to iterate over the string input and uses the provided dictionary in the form of key to convert it to Morse code. And then we also have read Morse, by which iterates over the Morse code input and plays its corresponding beep either in the form of dot, dash, or delay. The difference between dot and dash is that dot comes at a single unit and dash comes to 3. We also have the options replay audio, reset, menu, and leave, by which utilize an input and requires the user to actually input to the terminal for the following command. And here are the functions used from the libraries, winsound and time. As a reflection, I would like to conclude that sound is a versatile and intuitive medium for conveying information, as it allows systems to effectively communicate to us, primarily through our sense of hearing. And I also realized from the vast amount of time that I worked on this project, long high-frequency beeps are really good at indicating system failure or for calling the most urgent attention to the user, and vice versa. I would like to end my presentation here today with a trivia that back in 1961, a group of scientists back at Bell Labs implemented the very first computer that could sing via the IBM 1794. And as a tribute to that, they actually added a small Easter egg that if you input IBM 1794 onto the terminal from the menu, you will get the following song. Thank you for listening.